from concept to project to detailing to financing. You've done every part of it, and now the real action starts on the shop floor, right? So this is key to it. And the message here is energy efficiency procurement is not just a purchase. It is very important, and we will understand. We will understand here what is the difference to finance. Yeah, is energy efficiency is not just a purchase. It is very important. And we will understand. We will understand here what is the difference to finance. Hello, am I audible clearly?
Yes, you are. You are.
Okay, thanks. So in the first session, we saw defining baseline and ideation. Second one, we saw finalization of projects. The third one was on financing of energy efficiency project. Fourth, today we will see procurement and then the implementation. And after implementation, then how to do daily and monthly monitoring and verification of the savings. Then operation and maintenance of energy saving projects. And then finally, we will see summary. So whatever queries you have or whatever point you want to suggest, please put it in the question answer box. Learning is the key, and that is the purpose with which we decided to take this 8-session series. We've been doing and implementing energy saving projects since last more than 15 years, and there have been several learning. So that is what we are trying to do by sharing through this 8-seminar series. So what we saw in the first one, that is defining the baseline. Friends, as you see, energy efficiency or energy conservation is actually a difference of two numbers, right? The difference of two numbers means before the project, how much was the energy consumption, and after the project, how much is the energy consumption, right? So before the project, what is the energy consumption? That is called as baselining, right? And defining this is key to success of your project, because once you have implemented the project, you cannot go back to the baseline, right? So you have to put it very, very correctly. And then after the project, whatsoever is the energy consumption level, and difference of these two numbers is your actual success, and that too over a period of time, right? And on the baseline, it is very important to have agreement of all the stakeholders, the production side, the financial side, right, and the engineering side. At least these three, right? And if ESCO is involved or OEM is involved, then they should also be transparently presented the baseline. Then and only then a good project is possible. We had strongly suggested to keep the baseline simple. In order to make it more accurate, many times we make it more complex, and that becomes very difficult, right? Now here, transparency from all the sides, whether be it client side or ESCO side or OEM side, is very important, and it helps in long run. Right baselining results into right diagnosis, and right diagnosis results into right ideation. Let me again elaborate it further. See, what happens is the moment you or we come up with a baseline, there is some energy number which is available with us. And those who have done several projects, they automatically they can understand, and they, as a reflex, they say that yes, there is a scope, right? And then it leads to right diagnosis, right? And the moment right diagnosis is there, then and only then right finding of projects, what we call it here as ideation, that is possible, right? And friends, energy saving is a long-term phenomenon, right? So here is the baseline versus post-project energy cost. So the top line in green color is your actual energy cost before the project, and the blue line is after the project, and the difference of that is the saving. And these are the accepted savings at the customer's end in an energy performance contract, right? So expectation from energy efficiency is always a difference between two numbers. The first one is your baseline, and the second one is the outcome of your ideation, right? So now we see here the importance of baseline as well as ideation, right? Because based on these two only, we come to those two numbers, and those two numbers are actual our success of all the energy efficiency initiative, right? So then on the ideation side, right, it has to start from the baseline, right? and not with a preconceived mind that in this area I can do this project, or in that area I can do that project. Maybe that might be the final conclusion, but it has to go through a process and not through a preconceived mind, right? And before ideation, the diagnosis is must. I mean, what is the reason for the losses, right? The reasons for the losses actually leads to identification of energy saving project, right? And that is why we always believe in carrying out a fresh project with every case, right? And not just repetition of the things, right? Here we also believe in doing some verification on the baseline, because that is important, right? Then with every ideation, right, we often lose an opportunity, right? See, what happens is, for example, there is a baseline, and on that you find that there is a project which is having a good energy saving project, and in that uh, you want to actually get some savings, and payback period is good there, right? So here, what happens is, if you implement that, and that happens to be, yeah, am I audible? Yeah, thanks. Extremely sorry for this technical glitch. Actually, we lost the link. So we were talking about key learnings from ideation, right? And in that, yeah. Is my screen visible? Yeah. So friends, let's proceed further, right? So we were discussing about point 5, right? See, what happens is, you may find that the payback period is good, and then you may implement that project. But what happens is, it may not be your best solution. And in that situation, what happens is, for your best solution, now the payback period has gone up because your first project has done the savings. So that is the reason we should not be too much technology driven only, right? Because once a project is implemented, right, your baseline is changing, right? And that is where you need to be very cautious, because if we settle with the second or third best project, we may lose the opportunity to implement the best project, right? And if we go wrong, right, then even then, our conservative estimate of energy saving calculations, right, should find it fit and should find it useful, right? So it should always happen that the actual savings should be more than the calculated savings. Right. So it's a massive exercise. Ideation is a massive exercise. So I repeat, expectation from energy efficiency is always the difference between two numbers. The first one, we get it from the baseline, and the second one is the outcome of your ideation, right? So always believe in this. Now, when we finalize the project, so our learning was that the project finalization must be on overall diagnosis and not just based on one idea which is feasible, right? And we need to do everything within the allocated budget, right? So it is often driven by budget, right? And finally, energy efficiency is always rupee invested versus rupee saved, right? And that is what drives the selection of the project, right? And also, how much is the GHG emission reduction which we are getting out of the project initiatives, right? And that's why we need to do it very carefully. right? And finally, the cumulative savings, right? If we are guaranteeing that it should be 10% saving, it should be 20% saving, it should be 25% saving, we must be able to achieve that. And that is why we often say that it is also an art, right, than just a science. And the learning has been, there are plenty of medicines in the medical shop, but doctor prescribes us a few, right, on the basis of the diagnosis. So that's how the selection of energy efficiency project needs to be there, right? Then we saw the financing session, right? Because unless and until financing is done, it's difficult to implement energy efficiency project, right? So with ESCOs role, we have seen that ESCOs, if they identify the project, then and only then they can guarantee the savings and they can deliver the savings, right? ESCOs are implementing the project as a turnkey contract basis, right? They will do everything, right, from procurement to implementation, right? Then financing has to be facilitated with the end users and not only with the ESCOs, right? Because ESCOs are not end of the day banks, right? Financing has to be facilitated to the actual end user of the energy, right? And here the philosophy is very clear that the EMI or the lease rental, right, what is to be paid every month towards implementation of the energy saving project, that number, right, should be significantly higher. That number should be significantly lower than the actual energy saving, right? So that there is a positive, net positive cash flow to the energy end user, right? And ESCOs have to maintain the savings, right? Month on month, year on year, right? And OEMs and ESCOs, both of them, right, need to work in tandem with each other, because all these technologies are actually coming out from OEMs, right? Whereas on the ground, ESCOs are making the savings getting realized. So in this way, it's not necessary that every energy efficiency project, right, has to go through a separate budget process, right? So let's come to today's topic, which is procurement of energy efficiency project, right? And here the message is, we need to remember that we are buying a performance and not just the product, right? Hence the basis is life cycle costing and not L1, right? So friends, we'll see this concept, how it is applied, right? So let's see top 10 points which are important here. Here, as we discussed, we are actually procuring the performance and not just the product, right, or any service or any project, right? So that's why we have to understand here, is it that the capital cost which matters or the operating cost, right? Now, how will we understand whether the capital cost matters or the operating cost matters? It is possible to understand this difference by understanding the life cycle costing. So we will see that with an example, right? And then what is the fundamental difference between a normal procurement and an energy efficiency procurement? We will compare them on 5 parameters, right? So finally, we will have to ensure that we are buying the product or the service, right, on the performance basis. And how can we ensure that, right? Then what is the process of energy efficiency procurement, right? Then in all this, what is the role of ESCOs? What is the role of OEM? What is the role of client? What is the role of other stakeholders, right? Because when everyone puts their best in a systematic way, then and only then energy efficiency project succeeds, right? And how we see future of energy efficiency procurement, we will share that also, right? Then we will have some case studies, right, and some retrofit technologies, right, which have been implemented and they are delivering very good results, and some more success stories. So friends, it's all about cost versus value, right? However, when we are doing this complete exercise, then accountability is the key, right? So who takes the accountability of the outcome? That is very important. So let's begin with the first point, right? So let's remember, we are procuring here performance and not just the product or the project or the service, right? The first question we need to ask, will my procurement result mean, will it deliver what is that I'm expecting, right? Then am I buying results or am I buying product or service? The moment I'm buying result, my thought process completely changes, right? Is there a surety of returns, right? Then what are these two numbers, investment versus return, right? And finally, even if there is a good return out of a good energy efficient technology, but then what is the comparison of all the other options? How is the ROI in all the other options? So we have to be very, very elaborate, right? At the end of the day, by doing all these initiatives, our utility bill cost must get reduced, and that is the key, right? And we have delivered this through almost up to more than 20% savings, right, by implementing 6 to 8 projects, and we are sharing that learning through this 8 session series. So friends, this is the key of today's session. This slide is very, very important, right? So please put your best focus here, right? So here what is happening, we will see here, is it the capital cost that matters or operating cost that matters? So we have taken 2 motors. One is the standard motor, right? Earlier it used to be called as IE1 motor, and we are going to compare it with the IE4 motor, right? We normally feel that it is the capital cost that matters, right? Because end of the day, whether you are putting capital cost or whether you are putting operating cost, you are finally trying to maximize your profit. There is no confusion in the end result, right? That is to maximize the profit, right? But we often believe that our profit is going to be more when our capital cost is low, but that's not the reality. Let's see that, right? So finally, it's a game of capex versus opex. Let's see that, right? So size of the motor is 11 kilowatt in both of the cases, right? Operating kilowatt of the motor is 9.8 versus 9.2, right? We will feel that what is this difference? Only 0.6 kilowatt. And operating efficiency at operating load, right? Because motor will have different efficiency level at different loading, right? So it is 84.6% versus 90%, right? Which is a difference of 6.4%. Again, we will say 6.4% difference in efficiency means what? So, but unless and until we quantify this, we cannot understand this, right? So annual operating hours is same in both of the cases, which is 7,000. Unit rate is 10 rupees per unit in both of the cases. Life of the motor is more or less, both of the cases is same, right? And let's see the annual energy cost in one case, which is the uh, um, inefficient case, 6.86 lakhs versus 6.42 lakhs. Again, the difference is not something which is eye-catching, right? However, when you see the life cycle costing, right? So it goes 68 lakhs versus 64 lakhs, right? Whereas the cost of the energy efficient motor, right? IE1 motor versus IE4 motor, if you compare them, so it is 45,000 versus 68,000, right? So when we try to buy a motor which is 45,000 versus 68, so we will see that, oh, this is so much costly. If you try to see the percentage difference between cost of both of the matter, it is quite high, right? But if you see the rupees saved in 1 year itself, so whatsoever is the incremental cost, more than that cost we are able to recover in the first year itself, right? Because here, in case of IE1 motor, we are incurring 45,000, but additionally we are incurring the energy cost, right? Whereas in case of IE4 motor, we are incurring a higher cost for procurement of the motor, but at the same time we are saving rupees. But the last line, which is life cycle cost. So life cycle cost turns out to be 4.37 lakhs, right? In 10 years. So it is difference between the life cycle cost of both of the motors, right? So this is phenomenal, right? And any case, the life of any motor, right, is usually more than 10 years, right? So here the number is very significant. So that is the reason life cycle has to be calculated, right? Calculation, saving potential might be here, there, that doesn't matter, right? But if you don't do the calculation, you will not get a feel of the difference in terms of what it is costing finally. So that is the reason we strongly recommend that always carry out a life cycle cost analysis, and then and only then take your decisions. So friends, by looking at this, we can say very clearly, cost is in energy consumption and not in capital, right? This is very, very important to understand. And that should drive our purchase decisions, our procurement decisions. It's the key. Now, how is both of the process completely different, right, with each other, right? Let's see that. So we will compare them on 6 parameters. So the first one is that what is that which is being procured, right? So in a normal case, it is we are either buying a product or we are buying a service. That's what we feel, right? Okay. Whereas in energy efficiency procurement, we are not buying a product or service, right? It may appear that finally we are buying a product or service, but we are not. What we are buying is the outcome, and that is savings, right? So sounds a bit odd that the saving is a overall result of something, but fundamentally the whole purpose of the project is buying savings, right? We have to use this word, buying savings. Then and only then focus on savings will be there, right? So what is the basis in both of the cases? In normal procurement, it is specification or scope of work, right? Specification is in detail, scope of work is also in detail, right? But whereas in energy efficiency procurement, the basis is life cycle costing. We saw that difference, right? Okay, there can be different methods of calculating life cycle costing. There can be different depth or different number of parameters for life cycle costing, but it has to be carried out. That is the key. And the focus is immediate needs. In normal procurement, it is immediate needs. Whereas in energy efficiency procurement, the focus is on long-term gains, right? Because you are not going to get gains in a day or two, right? You are going to get the gain over a period of time, right? Now, what is the criteria, right? For if the different parties are technically qualified, then usually the criteria for normal procurement is L1, right? That's how the purchase department functions, right? Whereas in energy efficiency procurement, it has to be maximum savings, right? So, what is the policy guideline which is differentiating both of these things? So, in normal procurement, it can again be said as L1, which is the lowest cost, right? For technically equally qualified items, right? Whereas in energy efficiency, it is QCBS. The QCBS stands for quality cum cost based selection, right? We are not focusing only on one parameter, right? We are focusing on both. That is your how much is your going to be your operating energy cost and how much is going to be your capital cost, and then you are arriving at the life cycle cost. And based on the life cycle cost, the difference of that guides your procurement process, right? So normal procurement processes are quite established, right? Whereas energy efficient procurement, we haven't seen in many corporates, right? Even top leading corporates, that this is very much established at the department level, procurement department level, purchase department level, right? So here orientation is very much necessary, and that drives. So the focus has to be on the quality side. That means the performance side. That means the saving side, and not on the cost. So how do we finally say whether we are buying performance or not? Finally, in every product or purchase decision, we have to reach to this question. So answer is very simple, right? Have we done life cycle costing, right? Now this life cycle costing can be done for a new item purchase, or this life cycle costing can also be done for any of your existing equipment, right? Does it make sense to discard the old equipment even if it is perfectly operating, right? And friends, all these kind of decisions have been done very rightly with two cases. One is whether it is four-wheeler driving or whether it is two-wheeler driving, right? That decision has been done by conscious by most of us, right? But at company level, we often feel that this is missing, right? Another thing which we have seen is the LED purchase, right? Whether it is for a residential purpose or even it is for a business purpose or in a factory, we see normally the LED deployment very fast. But other than these two technologies, so many other technologies which are there, which can reduce the energy cost, right? So acceptance for that is not as high as these two. Friends, whatsoever your questions are, please do keep putting them in the question box. We will be discussing them and answering them at the end of the session. So what should be the process of energy efficiency procurement, right? So we have put in our 10 to 12 years of experience, and then we have defined this, right? And this is what we believe in, and this is what we also keep recommending all the customers, right? Make your overall energy cost saving target, right? See, if your target is 5%, then your overall procurement process will be different than when your target is 30%, right? This is the key. So target, it has to begin with your target, right? Then you will have to identify your partner, right? Be it your OEM, be it your service provider, be it your ESCO, or be it anybody, right? It's not possible. right? Just to do these kind of initiative completely with internal efforts, right? Then identify the energy efficiency projects with investment and ROI, right? Now the fourth step is very important. Who is belling the cat, right? I mean, who is taking the responsibility whether this much of investment will result into this much of savings or not, right? So here ESCOs come far different than everyone else, right? Because they take the responsibility that if they are claiming that this much of savings will be there, right, then they are responsible for delivering that much of savings, and that happens. And that's how the role of ESCO is clearly different, right? So we strongly recommend that the procurement of energy efficiency project must be led by the person or by the team or by the organization who is actually belling the cat, right? Because end of the day, if savings are not there, we are going to ask him, right? Or the company. Okay. Now, you need to have your measurement system in place. You need to monitor your progress, right? And we have to continuously keep on watching, are we reaching to the projected savings? That's the sixth step. Sixth step is your check and balances, right? And then you have to keep communicating progress and expectations to all the stakeholders. Cases savings might be less, some cases savings might be more, but all the stakeholders should transparently know what's happening. So friends, here are some of the case studies I've shown in earlier sessions also, but these are very, very important and very relevant. So we'll see them again. See, the basis or the beauty of any energy saving project is how do you put it in a way so that your monthly EMI or lease rental, right, is significantly lesser than your actual savings. So you'll find here that your monthly savings are 5.74 lakhs, that is item number 3, right? Whereas your monthly EMI is 3.84 lakhs. So you are actually getting a net positive cash flow of around 1.9 lakhs. So this is the key, right? And such projects are getting financed and getting implemented, right? And here the energy cost saving works out to be 65% and GHG emission reduction is by 95%. And what has been done here is actual electrical heaters, right, has been replaced by solid renewable fuel fired thermic fluid heater, right, for generating hot air in a plastic industry. Okay. Then the second case, right, it is about evaporative condenser in the air conditioning circuit. So here the monthly EMI which is to be paid, right, is around 58.5 thousand, whereas the savings are 89,500, right? So there is a net positive gain or net positive cash flow benefit of around 31,000 rupees. Right. So this is how the energy efficiency project needs to be structured, right, and needs to be recommended. And then the acceptance by the management phenomenally improves. So similarly is the third project wherein the air conditioning system has been modified, right? And here also the project is structured such that the monthly EMI which is to be paid is 2.85 lakhs, whereas the savings are 3.61 lakhs. And the difference of that is a net positive cash flow gain of around 77,000 rupees. Right? So friends, just to summarize, it's a multiple stakeholder activity, right? And that is why the right coordination between all of them is absolutely necessary, right? OEM's role is very important in energy efficiency project, even if ESCO has taken all the responsibilities, right? Because the technology belongs to them, right? And savings guarantees are taken by the ESCOs, right? So roles are different, right? And that is why the simple and the best example of a cricket team, right? There are 11 players, right? But each one of them has a different role to play, right? So friends, what we see as future of energy efficiency project procurement through ESCOs. So it is going to be like this, right? The genesis of anything and everything has to be the life cycle costing, right? And it doesn't matter who calculates, right? And even if there are slight calculation mistakes, your decision making will not go wrong, because end of the day, you will apply all those quantitative methods to finally make a call should this project be implemented or should it not be implemented, right? But having life cycle costing in place for your every decision making is most important, right? So when ESCOs identify the project, they are in a position to deliver the guaranteed savings, right? They implement the project on turnkey basis because they have to finally demonstrate the savings. Then ESCOs have been there in position to facilitate financing for the end users, right? And deliver the annual monthly EMI or the lease rental, right, which is significantly lesser than the monthly savings. So that's how the project is structured, right? And customer is delivered with a positive cash flow, right? And the savings are maintained, right? And in all this process, right, the relationship with OEMs, right, is well maintained. So friends, these have been some of the case studies, right? This is a case of Taj Vivanta, which is in Delhi, right? We did an investment of around 2.37 crores and delivered a savings of around 2 crores um, per year, right? And it resulted into GHG emission reduction of around 2.3 K metric tons, right? And ROI was around 85%. And the projects involved were chiller controller, CTI approved cooling tower, VFD on AHUs, right? LED lighting, then laundry revamping, auto tube cleaning system, heat pump. Friends, the number of technologies are phenomenal, right? And it's not that this is good or that is not good, right? It is basically like every patient has a very significant and very separate diagnosis. So like this, every case is very different. So a combination of energy efficiency project has to be evolved so as to deliver us best of the results, right? So this is the actual energy saving achieved. So the green color indicates the baseline, right? Whereas the blue color and the maroon color, right, is actually indicating the energy cost in 2 different years, right? So this is how savings have been maintained month on month. These are some of the projects which we have implemented. This is the first one is auto tube cleaning system. This helps in improving the condenser performance in chillers, right? So that your savings in chillers significantly improves. This EC fans, right, helps you in reducing your energy consumption in your AHUs. The heat pumps, right, actually delivers you, in addition to hot water, it delivers you chilled water, right? There's a dynamic controller which works on the chiller and it gives you additional savings, right? This is evaporative condenser. One of the case study we saw it in the earlier slides, right? Even in case of water cooled chillers, the evaporative condensers have given savings, right? But these are not generic. Like if it is, I'm not meaning that this has to be like घर के सारे बदल डालो, not like that, right? Every feasibility has to be evolved for every single case because there is something or the other which is different, right? Then cooling tower institute approved cooling tower definitely makes a significant difference, right? Then steam line generation from different sources near to the consumption point. So this helped in stopping the whole of the boiler itself, right? And all the batch processes, right, required actually steam at a very scattered portion of time, right? So this helped in saving all the distribution losses, right? Then servo stabilizer, it's a wonderful technology, right? But this is applicable only where the voltage variation is significantly high, right? It's not that we need to install this kind of system everywhere, right? And the case of energy efficient motor, right? Now I4, I5 motors, right, are there, and savings have been quite phenomenal. In some of the cases, we have found that the savings are as high as 20%. So this is a set of different technologies. This is a set of different projects and the outcomes of the savings. So the number of options are phenomenal, be it the number of technologies which are available, be it their potential, right? But the key is in implementing every project case by case and actually delivering the savings. So friends, just to summarize in simplest possible manner, this slide, this is my last slide, right? the first step has to be cost analysis, right? There are different sources of energy, there are different forms of energy, right? We need to put their cost, right? And then we have to find out in step two, what is the opportunity, where is the opportunity for energy cost savings, right? And then we have to optimize, because there would be several opportunities for savings. That doesn't mean that we have to do all the projects, right? Which are the projects which are best suited, right? And their combination, how are they going to perform? That is also very, very key, right? In medicine cases, we normally see that what is the side reaction of any medicine, right? So similarly, what happens is when we implement one particular project, it definitely impacts several other things. So that has to be very clearly evaluated. And then after doing all the step one, step two, and step three, we have to transfer the saving. Why we use terminology called as transfer the savings? Because it has to be completely believable part of the savings. So thank you very much for the patient hearing. Now I'll go to the questions one by one. Kunal, can you help me in that?
Yeah, sure.
Yes, please.
So the first question is, just a minute.
Kunal, actually, I am also able to see. Yeah. So very good question. That is the first question. Yeah, Kunal, can you read it out?
Yeah. How to establish the baseline if the energy is metered at building level and the retrofit is planned for a particular facility?
Very, very good question. See, fundamentally, there are four methods of energy saving calculations, right? And these four methods are worldwide accepted. So in the baseline session, we had elaborated on this. What happens is you can do it both ways, right? Like for example, if you are doing a retrofit project at a particular facility, like for example, in the building there is a chiller, right? And in the building there is lighting or there are several other loads. But when you are carrying out project only on the chiller, right, then it is better to demonstrate energy saving at a chiller level itself, because at other sides of the building we don't know what consumption are getting down or what consumptions are going up, or some new machines or some new thing or some new load is adopted, right? So this is why the fundamental concept of baselining is very important, right? Like for example, if you are doing a lighting project, let me take this question with a simple example of lighting project. So lighting project would straightway be before what, after what, multiplied by operating hours, right? There is no doubt about these wattage consumptions, right? If you are taking any energy efficient motor project, right, then also for constant load application, you can measure the motor kilowatt before and after, and you can demonstrate the savings by that, right? However, like the project which we had done at our various Taj hotels, right, wherein the customer said, this is my energy bill, this is my 12-month energy bill, and you do whatever energy saving project you want, you deliver us 20% savings, right? You and we took that challenge, and we said that fine, we will invest, right, and we will share the savings, right? So there we had to demonstrate savings on the utility bills level, right? So that is at the building level, right? And there it was not one project, we did several projects, right? 6 to 8 projects, right? And we extrapolated the savings at the building level, right? And then we ascertained in every case it should be more than 20%. So it's not that this method is correct or that method is correct. We have to arrive at a particular method, and that particular method should be acceptable to everyone, right? Whether it is plant's internal effort, right? They have to demonstrate the savings to the finance department, or whether any energy auditor is involved, or whether any ESCO is involved, or whether the deal is directly with the OEM, right? Anyway, this project can be done, right? But the defining the baseline and measuring the energy consumption post project activity, and the difference of these two things is the key. Yeah. Next question, please.
Yeah. Next one, while calculating the savings, the comparison between the baseline and post implementation of project has to be made on apple to apple basis. How to compute and adjust the previous conditions with the conditions prevailing during the post implementation of the project.
Very important question. See, what happens is, I'll share our own experience. Like, for example, in the hotel business, right? The occupancy changed, right? And then the banquet, right? So these are the two main sources of hotel income, wherein the occupancy and the banquet, right? But these are measurable, right? So at the time of baseline, how much was this, right? So that is also documented. And post project implementation, also it is documented. So if your occupancy is increased, then your actual savings will be shown lesser. Or if your occupancy is lesser, then your actual savings will be shown higher. So there is a regression method, right, which is applied here to take care of this thing, wherein you make both of the situation exactly as rightly put here, apple to apple basis. But that method of regression, right, it has to be detailed out in your contract before implementation of the project, that in case of variation in occupancy, right, how we are going to arrive at the equated condition, right? And that too also should be with a complete example. And there everybody should have a acceptance. So the post project, there is no conflict, right? And this is done very, very carefully, right? And there is acceptance. And these methods are IP-MVP guidelines, right? And worldwide, luckily there's only one single guideline which is worldwide accepted, that is IP-MVP guideline. And then these IP-MVP guidelines are having four methods. Method 1, method 2, method 3 is your facility level energy saving. And it is very clearly defined in the contract. And then and only then the project should be executed. And that is the reason why we are emphasizing in 8 different sessions, all these 8 different aspects which are key to implementation of energy efficiency project. Yeah, I think there was power outage, right? And the video connection is interrupted. We are sorry for that, right? What we will be doing is that this complete session is recorded in a YouTube link, right? And we will be sharing this YouTube link with all of you, right? And if after that also, if there is any doubt, please do let us know. We will specifically be responding to all those points. Any other question, Kunal?
Yeah. So if there's one question, so like if we the procurement is based on the payback, then how to justify the inflated project cost?
See, that is where the importance of life cycle costing is, right? See, what happens is the purchase department often feels that how much is money going out in that deal, right? This is project to be done. Then there are different parties who quotes, right? And then what happens is after different parties have quoted, then who is the L1, right? So that is how it goes, right? Whereas anything wherein energy efficiency is significant or energy cost is significant, the fundamental basis of procurement should not be project cost, should be the life cycle cost. Because then in energy cost form, your money is going out. Okay. And whatever is money going out in form of energy cost, that is normally believed that this is something, this is there, right? But that's not the case, right? The way we have put the plant, the way we have put the facility, the way we have taken our all the purchase decisions, those are the decisions which decides tomorrow's energy cost. So that's the key. Yeah. Any other question?
One more. Yeah. So how to address the service issues related to energy efficiency procurement?
See, service issue is the key, right? And we often suggest or equate with services. How do we take services of doctor, right? And that is how it should be, right? Because you are ultimately looking forward to the ultimate benefit, right? that whatever element we have, that should be completely eradicated. So if that is the basis, then and only then these procurement goes right. Otherwise, these procurement go wrong. And the life cycle costing is a simple concept. There is no big technical jargon, right? But it is not carried out, right? And even if it is carried out, it is carried out at a vendor level. Whereas the end customer, it is their responsibility to do the life cycle costing, right? Because if the vendor is doing it, they may not believe it, right? But if they have done it themselves, right, then their belief on that technology or in that project, right, will be there. They can ask for the guarantee from the ESCOs. That's not the issue. And ESCOs will give them guarantee, right? But that will at least give them a right calculated life cycle costing, right? And their decision will be on the basis of life cycle costing. And if that is not done, the energy efficiency procurement can never be done correctly.
Yeah. Thank you, Milind sir, for the answers. And these are all questions we have. Yeah. Thank you.
Thanks, Kunal. Thank you, everyone. So please do join us next Tuesday, same time. Today my voice was also not good, but I thought that I have committed, so I must make the presentation. This presentation will be available in totality on YouTube, right? So if anything is left out, you can refer from that as well, or you can write to us also for anything. Okay. So thank you very much. See you all next Tuesday. Bye. Thank you.